The next material of 3D tile is the next building material is 3D tiles. 3D tiles are open specification for streaming massive heterogeneous 3D geopastical datasets. 3D tiles are used to stream 3D content including building, trees, point cloud and vector data on flooring tiles, roofing tiles, wall tiles. These tiles gives a decorative look to a building unit. This is the picture showing 3D tiles placed at floor. So our next part of this chapter, second chapter, is road materials. The need for seeking advanced road construction material includes it reduces cost, conservation of resources, reduce ecological footprint, extended service life, optimize use of locally available materials, achieving environmental benefits such as reduction of carbon footprint, reduce congestion related emissions, etc. Reduce work zone, relate traffic delays and safety concerns, use materials that reduce the potential for early failures. So in road material, very first material is geosynthetics. Geosynthetics are an established family of geomaterials used in a wide variety of civil engineering applications. Many polymers, that is plastic, common to everyday life are found in geosynthetics. The most common are polyolefins and polyester. Although rubber, fiberglass and natural materials are sometimes used, geosynthetics may be used to function as a separator, filter, planer, reinforcement, cushion protection and as a liquid and gas barrier. The various types of geosynthetics available along with the specific applications. Geosynthetics are synthetic products used for stabilized terrain. They are generally polymers products used to solve civil engineering problems. This includes 8 main product categories like geotextile, geogrid, geonet, geomembrane, geofoam, geocells and geocomposites. The polymeric nature of the products makes them suitable for use in the ground where the high levels of durability are required. They can also be used in exposed applications. Geosynthetics are available in a wide range of forms and materials. These products have a wide range of application and are currently used in many civil, geotechnical, transportation, geoenvironmental, private development applications including roads, airfields, railroads, embankment, retaining structure, reservoirs, canals, dams, erosion control, sediment control, landfill liners, landfill covers, mining, aquaculture and agriculture. This is the picture of geosynthetics used at a road surface. So geosynthetics has certain advantages. There are many advantages like space saving because it has a sheet like structure. Geosynthetics take up an less space in a landfill than do comparable soil and aggregate layers. Second is material quality control. Soil and aggregate are generally heterogeneous material that may vary significantly across a site or borrow area. Geosynthetics on the other hand are relatively homogeneous because they are manufactured under tightly controlled conditions in a factory. They undergo rigorous quality control to minimize material variation. Third advantage is construction quality control. Geosynthetics are manufactured and often factory prefabricated into large sheets. This minimizes the required number of field connections or seams. Both factory and field seams are made and tested by trained technicians. Conversely, soil and aggregate layers are constructed in place and are subjected to variation caused by weather, handling and placement. The fourth advantage is cost saving. Geosynthetic material are generally less costly to purchase, transport and install than soil and aggregates. Fifth advantage is technical superiority. Geosynthetics have been engineered for optimal performance in the desired application. Next one is construction timing. Geosynthetics can be installed quickly, providing the flexibility to construct during short construction seasons, breaks in inclement weather, or without the need to demolish and remobilize earthwork. Next one is material deployment. Layers of geosynthetics are deployed sequentially but with a minimum of stagger between layers, allowing a single crew to efficiently deploy multiple geosynthetic layers. The second last one is material availability. Numerous suppliers of most geosynthetics and ease of shipping ensure a competitive pricing and ready availability of materials. And the last one is environmental sensitivity. Geosynthetic systems reduce the use of natural resources and the environmental damage associated with quarrying and trucking and other material handling activities. Here are some properties of geosynthetics. Very first one is woven geotextile, which is having high strength, high tensile strength and low strain, or we can say it as limited elongation under load. Second one is geogrid, which is having low strain and stretch only up to 2 to 5% under load. They can take up heavy load also. While geotextile, geogrid and geocells are porous to allow water to filter through them. Geomembranes have low permeability and are used to control fluid movement. Geosynthetic materials such as tubes, mats are used for erosion control. They are biodegradable and include straw and coconut malting. Here are some uses of geosynthetics. Geosynthetics used to improve level grade soil situations such as roads, valleys, laneways, to improve slope grade situations such as banks, hillsides, reinforced soil such as soil wall, bridge abutment, box culverts, bridges and soil arches, prevent soil movement like while letting water move through the material, control water pressure allowing flow in the plane of material such as foundation walls. These are the types of geosynthetic material. Very first one is geotextile, which is used for drainage, separation and reinforcement. Geogrids, which are open mesh like material used for stabilization and reinforcement. Geocells are cavity like material in a web used for stabilization. Geomembranes are low permeability liner or fluid containment material. Erosion control materials that are biodegradable or non-biodegradable. So next road material is noise reducing asphalt. Asphalt pavement used in road design. One important way noise can be reduced is by using asphalt for pavement. A dense graded hot mix asphalt, that is HMA pavement, is quiet at 100 feet away from the road, as the Portland cement concrete, that is PCC, is at 200 feet away. One asphalt mix called as open graded friction courses, that is OGFC, is especially helpful in reducing noise because it is porous. It has a higher ratio of air voids, which helps water runoff but also help absorb road noise. Asphalt pavement can be made even quieter and even more eco-friendly when recycled tires are mixed in. This is called as rubberized asphalt. Noise tests on rubberized asphalt have shown a 50 to 90% reduction in noise. White asphalt pavement can help reduce highway noise such as 7 decibels according to a study. Reducing noise by just 3 decibels is equivalent to doubling the distance from the source of noise to the listener, according to asphalt pavement literature. Quiet asphalt pavement options fall into 4 general categories. These are fine graded surface, open graded friction courses, rubberized asphalt and stone matrix asphalt. Fine graded surfaces are conventional asphalt, that are mostly composed of fine grade particles, reducing the apparent road noise generated by the expelled air by altering its frequencies. Open graded friction courses, that is OGFC, are a porous mix with more connected voids through which air and water can escape. Rubberized asphalt contains crumbs of recycled tires that provide some flexing in the road surfaces as tires pass over it, allowing the air a bit more time to be forced out at lower pressures. Stone matrix asphalt mainly uses coarse aggregate to create a stone skeleton tied together by asphalt binders and fibers. This is the picture showing laying of asphalt on the road surface. Next one is porous pavement. Permeable pavement is a porous urban surface composed of open pore pavers, concrete or asphalt with an underlying stone reservoir. Permeable pavement catches precipitation and surface runoff, storing it in a reservoir while slowly allowing it to infiltrate into a soil below or discharge via a drain tile. The most common uses of permeable pavement are parking lots, low traffic roads, sidewalks and driveways. Permeable pavement surfaces are made up of either a porous material that enables storm water to flow through it, or non-porous blocks paste so that water can flow between gaps. Storm water flows into and is stored in an underlying stone reservoir. Permeable pavement is commonly used on road, path and parking lot subject to light vehicular traffic such as cycle path, service of emergency access lane, road and airport shoulders, and residential sidewalk and driveways. Permeable pavement is a porous urban surface composed of open pore pavers, concrete or asphalt with an underlying stone reservoir. Permeable pavement catches precipitation and surface runoff, storing it in a reservoir while slowly allowing the infiltrate into the soil below or discharge via drain line. Permeable pavement is a porous urban surface composed of open pore pavers, concrete or asphalt. Permeable paving is a method of paving vehicles and pedestrian pathway to enable infiltration of storm water runoff. Permeable pavement surface typically include pervious concrete, porous asphalt, paving stone and interlocking pavers. These are porous pavement placed as vehicular road and also as pedestrian road. Here are some general hydrological benefit of porous pavement. Permeable pavement help re-establish a more natural hydrological balance and reduce runoff volume by trapping and slowly releasing precipitation into the ground instead of allowing it to flow into storm drain and out to receiving water as effluent. This same process also reduces the peak rates of discharge by preventing large fast pulses of precipitation through the storm water system. Permeable pavement can reduce the concentration of some pollutants either physically by trapping it in pavement or soil, chemically by bacteria and other microbes can break down and utilize some pollutants, or biologically that plants that grow in between some types of pavers can trap and store pollutants. By slowing down the process, permeable pavements can cool down the temperature of urban runoff, reducing the stress and impact on the stream or lake environment. By controlling the runoff at the sources such as a parking lot, permeable pavement can also reduce the need for the required size of a regional BMP such as a wet detention pond, which saves money and effort. Next road material is plastic road. Plastic road are made entirely of plastic or of composites of plastic with other material. Plastic roads are different from standard roads in the respect that standard roads are made from asphalt concrete, which consists of mineral aggregate and asphalt. Plastic bitumen composite roads have better wear resistance than standard asphalt concrete. They do not absorb water, have better flexibility, which result in less rooting and less need for repair. Road surfaces remain smooth, are lower maintenance and absorb sound better. Plastic used in road construction is not new. It is already in use as PVC and HDP pipe mat crossing built by cabling together PVC, that is polyvinyl chloride, or HDP, that is high density polyethylene, to form plastic mats. The plastic road include transition mats to ease the passage of tires up to and down from the crossing. Both options helps protect wetland howl from rutting by distributing the load across the surface. But the use of plastic waste has been a concern of scientific and engineers for a quite long time. Recent studies in this direction have shown some hope in terms of using plastic waste in road construction, that is plastic roads. Plastic roads mainly use plastic carry bags, disposable cups and PET bottles that are collected from garbage dumps as an important ingredient of construction material. When mixed with hot bitumen, plastic melts and form an oily coat over the aggregate, and mixture is laid on the road surface like a normal tar road. Plastic coating on aggregate is used for the better performance of road. This helps to have a better binding of bitumen with plastic wasted coated aggregate due to increased bonding and increased area of contact between polymer and bitumen. The polymer coating also reduces the voids. This prevents the moisture absorption and oxidation of bitumen by entrapped air. This has resulted in reducing rutting, revealing, and there is no pothole formation. Next one is solar roads. The solar roadway produces clean, renewable energy, no pollution, no greenhouse gases, no byproducts, and the solar road panels are completely recyclable or reusable. The main cause of global warming is creation of electricity by fossil fuels, which will contribute to production of greenhouse gases and effect on ozone layer. The solar roadways eliminates this, half of the cause of global warming entirely. The solar roadway, being an electric road, will also make all electric vehicles more practical. Recharging stations can be placed in all parking lots and rest stops. This will allow the all electric vehicles to have the same driving range of current internal combustion gasoline or diesel powered vehicles. Elimination of internal combustion engines, which will now be feasible with the solar roadways, will wipe out most of the race of the causes of greenhouse gases. There are many other features including wildlife preservation, the elimination of impervious surfaces, low enforcement, DUI detection, counter terrorism. An intelligent highway infrastructure and a self-healing decentralization power grid that will eliminate our need for fossil fuel, and also it will lead to less invest in antiquated technology, wise asphalt and overhead power lines. As the day by day the prices of petroleum products are getting huge hike and resources are very less, there will be no longer feasible materials such as asphalt for our road surfaces. When solar road panels are refurnished, the solar cells will be upgraded to newest technology, which will allow keeping up with population growth and increase energy needs Also, if such technology is furnished in any of the country will require approximately 5 billion solar rods for covering roads, parking lots, driveways, etc. And also, such technology will create millions of green collar jobs. The solar roadways can save the wonderful countries in the world. The day by day, the human beings are looking for the answers to our deteriorating highway infrastructure, our crumbling power grid, and the climatic crisis. For all such questions, the answer is solar roadways. The solar roadway consists of structurally engineered solar panels that we drive on. Each solar panel, roughly 12 inch by 12 inch, interlinked with a neighboring panel to form a solar roadway system. The solar roadway replaces our crumbling petroleum based asphalt highway infrastructure with an intelligent road that pays for itself through the generation of electricity. The solar roadways generates electricity power from the sun and becomes our nation decentralized, intelligent, self-healing power grid, replacing our current deteriorating power distribution infrastructure. The solar roadway distributes its electric power to all businesses and homes connected to the system via their parking lots and driveways made up of solar road panels. In addition to electrical power, data signal, cable TV, high speed internet, telephone, etc., also travel through the solar roadway, which acts as a conduit for the signals. This feature eliminates the unsightly power lines, utility poles, and relay stations we see all over the countryside. It also eliminates power interruption caused by fallen or broken electric lines or poles. Each solar road panel uses some of its power to light up embedded lights, LED lights, which paint the road lines from beneath the road surface. These features also allows messages to be spelled out in the road surface, such as slow down or accident ahead. Road lines can be instantly repainted to direct traffic to the signal lane or to deter. This eliminates the need for cones and flares. Better visibility at night with the road lines illuminated. It will be like driving on the well lit runway. Solar roadways is a modular system of specially engineered solar panels that can be walked and driven upon. Our panels contain LED lights to create lines and signage without paint. They contain heating elements to prevent snow and ice accumulation. The application for solar panels are growing exponentially. Photovoltaic cells work by using semiconductors to absorb light and create a flow of electrons which can power any number of electrical devices. Put the two together and you get a unique solution: solar panels on our highways. Solar roadways panels are made up of tempered, that is safety glass. Glass was chosen for its hardness, strength, durability, and transmission. SR glass is textured to create a proportion fraction for vehicles and pedestrians. This is a figure of solar road. The 12 inch by 12 inch solar panels are jointed together and placed on the road surface. Next one is anti-icing road. Firstly, we have to define anti-icing. The application of chemicals to road before a snow pavement bound occurs. Anti-icing emphasizes prevention rather than reaction. Anti-icing is a proactive approach to winter road maintenance. It forms a bond breaker between the pavement surfaces and a snow and ice layer, which melts snow more quickly and reduces the chance that ice will form and bond to the surface. Sodium chloride, that is salt, magnesium chloride, calcium magnesium acetate, and potassium acetate are chemicals used to prevent and remove snow, ice from roadways. VDOT uses liquid magnesium chloride, calcium chloride, and sodium chloride for anti-icing and pre-treatment. Anti-icing is a proactive approach to winter road maintenance. It involves the application of anti-icing products, also known as freezing point depressants, to the roadway before a winter storm. It forms a bond breaker between the pavement surface and the snow and ice layer, which melts snow more quickly and reduces the chance that ice will form and bond to the surface. It is similar to how cooking oil prevents food from sticking the frying pan. Anti-icing reduces the amount of time required to restore the roads to a clear, dry state. ND NDDOT uses snow plows, tankers, automatic bridge brake sprayers, and other equipment in the anti-icing process. Effective anti-icing is dependent upon having the right amount of anti-icing liquid in the right place at the right time. Applying anti-icing liquids to the roadways is generally the most effective approach to prevent icy and snow compacted roads. There are many factors that go into determining if anti-icing will be effective. Some of the factors are air temperature, wind speed, precipitation type and intensity, current pavement condition and location. NDDOT uses these factors in an advanced weather forecasting system, as well as the experience that of our maintenance crews to determine when and where to anti-ice. Anti-icing is a proactive approach to winter road maintenance. It forms a bond breaker between the pavement surface and the snow and ice layer, which melts snow more quickly and reduces the chance that ice will form and bond to the surface. It reduces the amount of time required to restore the roads to a clear, dry state. Reduced use of abrasives on the road result in reduced environmental impacts. Snow and ice control cost saving results in benefits to NDDOT and the public. Improved winter roadway conditions result in safer driving conditions for motorized. Lower accident rates, that is, Colorado experienced an average decrease of 40% in snow and ice related crashes during a 12-year study utilizing the anti-icing process on the interstate system. NDDOT applies liquid product directly to the roadway to prevent the built up snow and ice by lowering the freezing point of weather, leaving the roads bare and wet when they would otherwise be covered by snow and ice. NDDOT primarily uses liquid in three ways. Anti-icing is the application of liquid to the roadway before or at the onset to a winter storm. De-icing is the application of liquid after snow and ice has compacted to the roadway. And DDOT experiences has been that it takes approximately 3 times the resources to remove compacted snow and ice when the anti-icing process is not used. The same effect is experienced when snow compacts on a driveway after driving on it several times and then trying to scrape it off. And third one is pre-wetting, is the application of liquid to granular salt mixture to help jump start the melting process. Sand alone cannot melt snow and ice, and dry salt must change into a liquid solution to melt snow and ice. Studies have shown up to 30% of dry salt or sand can scatter or blow off the roadway, so liquid is added to the salt mixture to prevent scattering and blowing, helping salt mixture stay on the roadway. This is a truck spraying the anti-icing chemical on the road surface. And the last type of road is piezoelectric road. Alternative energy will become increasingly important as fossil fuel supplies eventually run out or environmentally damage sparks consumer awareness. The search for a viable energy alternative will continue until this alternative can address the dynamic demands of the electric grid and storage limitations. Piezoelectric devices used for harvesting the vibrational energy of road and walkway due to traffic can produce electrical energy that is predictable, that is based on traffic patterns and locally storable. Piezoelectric devices generate electrical energy by means of piezoelectric crystal electric floors are designed to capture the wasted energy and resources and store or redistribute them where they are needed. Energy is generated when a person steps on tiles that features piezoelectric attributes. This kinetic energy is converted into electricity. The crystals placed about 5 centimeters below the surfaces of the asphalt slightly deforms when vehicles travels across the roads, thereby producing electric current. The generating capacity of piezoelectric devices can be crudely over approximated by assuming that the vibrations in the road are caused by traffic alone, and that each vibration event from the one vehicle is independent of another, that is, the vibrations are sufficiently damped before the next vehicle passes. Under this assumption, the total energy harvested by piezoelectric devices along a 1 kilometer stretch is at most the number of cars that pass multiplied by the vibrational energy that one car transfers to the road. This vibrational energy can be over approximated by the energy that each car consumes and puts to mechanical work across the stretch. In other words, the energy a car losses to vibrations in asphalt must be less than the energy a car puts the mechanical work over the 1 kilometer stretch. This value can be computed by multiplying the energy consumed from gasoline by thermal efficiency. Having met the power matrix, they will make such invention a starting point to self-sustaining environment by being dependent on vehicle element to curb down input energy and cost. This will be a revolution in the production of energy by meeting innovations and technologies to shape future energy. However, further concentration is required to quantify and result in a greater power outcome to become a reliable source of electricity. This is the picture of piezoelectric rods. The energy, the electrical energy is made with the help of vibrations. Here are some limitations of piezoelectric rod. Piezoelectric rod's integrated technology is a new energy evolution, and hence piezoelectric awareness and expertise in this sector are very limited. This was also observed in primary data collected using questionnaires and interview to have obtained invalid and biased information. The power matrix provided by vendors does not provide additional technical detail. The vendors were compared using vibration based factor only. Other technical factors were not analyzed in terms of piezoelectric geometry, structural and thickness. This is common, having not to reveal a full technical support of this technology to preserve invention rights and securities effective business strategies. Implementing piezoelectric rod technology on a field required a standard specification in the execution process which has not been established. This is important as to use appropriate management and methods to prevent manipulating with roads infrastructure and minimizes traffic congestion.